In the winter of 1940, the United States was not ready for war. Its army ranked 17th in the world, smaller than Portugal's. Its Air Force, officially the U.S. Army Air Corps, possessed fewer than 2,000 modern aircraft. The nation had been shaped by the Great Depression, by the memory of the Great War, and by a deep reluctance to fight abroad again. But in Europe, the storm had already begun. German tanks rolled through France, and the Luftwaffe darkened the skies above London. The world's future would soon depend on how quickly America could transform itself from an isolated republic into an industrial fortress. At the heart of that transformation stood one question: could a nation built on cars, radios, and refrigerators learn to build warplanes faster than anyone in history? The answer would come from the assembly lines of Detroit. When President Franklin Roosevelt declared that America must become the arsenal of democracy, he wasn't speaking to soldiers. He was speaking to engineers, foremen, and factory workers. The automobile plants that had once turned out Fords, Buicks, and Chevrolets would now turn out engines, tanks, and aircraft. It was a gamble on an unprecedented scale, one that would decide whether the Allies could win control of the skies. Henry Ford, already a symbol of mass production, stepped forward with a bold proposal. If he could build a Model T every few minutes, why not a bomber? His company designed a factory at Willow Run, Michigan, a plant so vast it seemed to defy imagination. More than a mile long, it would employ tens of thousands of workers and produce one B-24 Liberator bomber every hour. The press called it the Grand Canyon of the Industrial Age. To Ford, it was proof that war could be won with logistics as much as with bullets. But the challenge was enormous. Automobiles were built for peace. Bombers were instruments of war. Each required more than 1 million individual parts, precise engineering, and skilled labor. Yet America had no time to wait. In the coming years, every man and woman who entered those factories would become part of a race against time, a race that would determine the skies of the Second World War.
Before the first bomber rolled off the line, engineers had to reinvent the way aircraft were built. Early warplanes were handcrafted, each slightly different from the next. For mass production, every bolt, bracket, and panel had to fit perfectly, whether made in Michigan or California. The American solution was standardization. Factories adopted precision gauges, interchangeable components, and conveyor systems that brought aviation into the modern era. By 1942, hundreds of subcontractors fed into a vast industrial web. A single bomber might include parts from 1,200 companies, from aluminum mills in Pittsburgh to rubber suppliers in Ohio. Women, who had rarely worked in heavy industry, now made up more than a third of the workforce. They drilled, riveted, and welded, their bandanas tied against the din of the machines. The name Rosie the Riveter became a national icon, representing not only labor, but resilience. Willow Run began operations under chaotic conditions. Workers arrived faster than housing could be built. Buses brought them in from miles away. The first months were filled with breakdowns and delays. But slowly efficiency improved. Engineers rearranged assembly lines, simplified designs, and introduced shift systems that ran 24 hours a day. By mid-1943, the factory was delivering bombers faster than any plant in the world. At its peak, Willow Run produced more than 8,000 B-24 Liberators. Each carried 2,700 gallons of fuel, 10 machine guns, and up to 8,000 pounds of bombs. They would soon become the backbone of America's strategic bombing campaign, the tool with which the U.S. intended to cripple Axis industry from the air.
As Ford perfected the bomber assembly line, other companies joined the transformation. Boeing, Douglas, and Consolidated expanded production of the B-17 Flying Fortress, while Lockheed turned out P-38 Lightnings in California. In Seattle, Boeing's Plant 2 became so vital that engineers built a camouflage roof to make it resemble a quiet suburban neighborhood from above, complete with fake streets and cars to fool Japanese reconnaissance. The coordination between government and industry became one of the greatest logistical feats in history. The War Production Board oversaw contracts, raw materials, and design standardization. Engineers shared innovations across competing firms, breaking peacetime rivalries for the sake of victory. The result was scale beyond precedent. In 1940, the U.S. had built fewer than 3,000 aircraft. By 1944, it produced more than 96,000 in a single year, nearly 260 every day. No enemy could match this pace. Germany, already strained by fuel shortages and Allied bombing, struggled to maintain even a fraction of its production. Japan's aircraft industry, fragmented and dependent on manual labor, lagged far behind. By contrast, American factories ran like clockwork, driven by electricity, automation, and morale. The term air superiority took on a new meaning. It was no longer only about the skill of pilots, it was about the machinery behind them, the invisible network of workers who made flight itself possible. For the first time, war had become a contest of production. By 1943, waves of American bombers were crossing the English Channel daily, their mission to destroy Germany's ability to fight. The strategy was controversial. Precision bombing meant daylight raids, exposing crews to flak and fighter attacks. The losses were heavy. Entire squadrons vanished in the cold skies over Bremen, Hamburg, and Schweinfurt. But each mission taught valuable lessons. Formations tightened. Escort fighters, first the P-47 Thunderbolt, later the P-51 Mustang, extended the bomber's reach. Radar navigation improved accuracy. Behind every success lay the power of production. Even when hundreds of aircraft were lost, replacements arrived within weeks. What Germany viewed as catastrophe, America viewed as logistics. Inside the Reich, Albert Speer, Hitler's armaments minister, understood the danger. He warned that if the Allied bombing continued, the war would be lost. Yet German intelligence struggled to comprehend the full scale of American capacity. Reports suggesting that the U.S. could produce 100,000 aircraft a year were dismissed as exaggeration. The truth was even greater. By 1944, the skies of Europe were filled with the evidence of America's industrial might. Bombers pounded factories, railways, and refineries day and night. The Luftwaffe, once feared for its dominance, was overwhelmed. Its pilots faced an enemy that could replace every loss tenfold. Air superiority had shifted permanently, and with it, the balance of the war. Across the Pacific, a different kind of air war unfolded. Japan's empire stretched across thousands of miles from Burma to the Solomon Islands. Supplying such a vast front required ships, and ships required control of the air. American carriers became floating airfields, each carrying squadrons of fighters and dive bombers. Yet the true revolution was coming from land, the arrival of the B-29 Superfortress. Built by Boeing and powered by Wright R-3350 engines, the B-29 was the most advanced bomber of the war. It could fly higher, faster, and farther than any aircraft before it. Its pressurized cabin, remote-controlled gun turrets, and enormous range made it the perfect weapon for the vast distances of the Pacific. Factories across Kansas, Washington, and Georgia produced thousands of them. Each B-29 required more than 100,000 individual parts and took 157,000 man-hours to complete. The aircraft symbolized America's shift from regional power to global reach. From the Marianas Islands, these bombers would bring Japan within striking distance, a development that would soon change the course of the war. In March 1945, B-29s began a new kind of bombing campaign over Japan. Under General Curtis LeMay, the U.S. Army Air Forces switched from high-altitude precision attacks to low-level incendiary raids. The goal was not to destroy factories alone, but the urban infrastructure that supported them. On the night of March 9-10, more than 300 bombers struck Tokyo with napalm and magnesium cluster bombs. The city, built largely of wood and paper, became an inferno. By dawn, 16 square miles of the capital were gone, and more than 100,000 people were dead. It was the single deadliest air raid in human history. From an industrial standpoint, it was devastating. Japan's production collapsed. Rail lines, warehouses, and power plants were obliterated. By summer, 66 Japanese cities had been burned to the ground. What had begun as a campaign of strategic bombing had become total destruction, a grim testament to what mass production could achieve. In August 1945, the war reached its final chapter. The atomic bombs dropped on Hiroshima and Nagasaki were products of the same industrial machine that had built the B-29s that carried them. The Enola Gay and Boxcar were both superfortresses from the 509th Composite Group, symbols of how technology and manufacturing had fused into a single force. The devastation was beyond imagination. Yet it also represented the ultimate expression of industrial warfare, a weapon built not in a lab, but through the combined effort of hundreds of thousands of workers, scientists, and engineers across the nation. On August 15th, Emperor Hirohito addressed his people, announcing Japan's surrender. The war that had begun with the thunder of aircraft over Pearl Harbor ended with a silence that stretched across the world. In the aftermath of victory, the same factories that had built the engines of war now turned to rebuilding the world.
Ford, Boeing, and Douglas shifted back to civilian production. The experience of wartime manufacturing had permanently changed the American economy. Automation, logistics, and engineering had reached new heights. The United States emerged as the first true industrial superpower, capable not only of fighting wars, but of defining the global order that followed. Aircraft technology advanced rapidly. Jet propulsion, radar, and long-range navigation, once secret wartime tools, became the foundation of civilian aviation. In less than a decade, the same systems that had carried bombers over Berlin would carry passengers across the Atlantic.
By the time peace returned, more than 300,000 aircraft had been built by American factories during the war. The number was staggering, but behind it lay something deeper. The realization that wars could be won not only by strategy, but by organization. The arsenal of democracy had become a philosophy, the belief that freedom itself could be engineered. Germany's intelligence had once doubted the reports of Willow Run. After the war, captured officers were taken to see it for themselves. They stood in silence at the edge of the empty assembly line, realizing that this, more than any single battle, had decided the outcome. The power of mass production had reshaped the 20th century.
As the Cold War dawned, the lessons of the Second World War remained clear. The jet age, the space race, and the global economy that followed all traced their roots to the assembly lines of the 1940s. The world had learned that machines could win wars, but also that they could build peace. America's rise to air supremacy was not just a story of planes and pilots. It was a story of workers, of engineers, and of belief in the power of innovation. From the first rivet driven at Willow Run to the final mission over Japan, the nation had proven that industry itself could be a weapon. And in that discovery, the marriage of production and purpose, the modern world was born.